In our last video, we had just introduced ourselves to the idea of estimating the area under a function's curve by using different rectangles. If your graph has a shape that's already a rectangle, that's cool. That allows you to get the area exactly. But in certain cases, you can't come up with an exact area formula off the top of your head. So you can estimate by using different rectangles, as we've done here for our parabola f of x equals 1 minus x squared. We're trying to approximate the green shaded area, but we broke it into two orange rectangles there and added together their areas to give us an estimate, but still too large of a value for what we're looking for. It's an overestimate. So now in this video, we're going to still work with this same function. This is still f of x equals 1 minus x squared, but we're going to refine the idea a bit more here of using rectangles to estimate. So what we're going to do for this particular sketch is we are going to use 4 rectangles instead of 2. Exciting. All right, so let's sketch in what those rectangles would look like our previous 2, but now there's 4. Okay. So let's kind of set up our x-axis first here. Let's split the interval evenly into 4 pieces. Okay, like that. And then let's draw in the rest of the rectangles like we did before. Okay, so there's, a rectangle. And then there's a rectangle. There's a rectangle. And here's our last rectangle. There we go. Okay, so we're going to get the area of those 4 rectangles. All right. So for each one of these rectangles, we're going to need the width and the height. Okay. The width, you can see, is going to be just 1/4 of a unit because we've taken our full 1 unit length here and cut it into 4 pieces. So each one of these rectangles is 1/4 unit wide. Okay. Where we're going to need to figure out a little bit more is with the height. So we're going to take 1/4 times the height of our first rectangle. We can see that that's 1. That goes all the way up to the top, the vertex of the parabola there. So 1. The next one, though, here's the point that we're basing the height off of. And just like our previous sketch, for the second rectangle here, we based our height off of this point. And that point was f of 1/2 because it lies on the parabola. F of x equals 1 minus x squared. The point down here was 1/2, so that y value was f of 1/2, giving the height of the second rectangle. So same type of idea here. This x value is 1/4. And so this y value right here is going to be f of 1/4. Okay. So I'm actually just going to put that for right now. 1/4 times f of 1/4. And then we can do the same type of thing for our next couple points. All right, for the third rectangle right here, the height is based off of the point 1/2. So we want f of 1/2, the height of that rectangle. We actually already calculated that in the last video. F of 1/2 right there was 3/4. Okay. We're going to need to calculate all of these heights there. But for right now, I'll just put 1/4 times f of 1/2. Okay. And then for our last rectangle here, the x value setting the height, because that's the height of our rectangle, okay. The point setting the height is x equals 3/4, and so that's going to be f of 3/4 for the height there. So 1/4 times f of 3/4 will give us the area of that last rectangle. Okay, so we have 1/4 times 1 plus 1/4 times f of 1/4. You can see I started plugging that in up here. We'd have 1 minus 1/16. That would be 15/16 for that y value. 15/16. There we go. 1/4 times f of 1/2, which is 3/4. And then 1/4 times f of 3/4, which is going to be 1 minus 3/4 squared. That would be 1 minus 9/16, and that would be 7/16. Okay, trying to save myself some space there. All right, so we could actually find a common denominator for all those. That would not be too crazy in this case. I'll let you crunch the numbers, but fraction-wise, that would turn out to be 25/32. Or if you want to do it as a decimal in your calculator, that'd be 0.78125. Okay. So this estimate, A equals 0.78125, is closer to what we actually wanted, the area underneath the parabola. So this is closer, but it is still an overestimate. There's still extra pieces in here, right here, here. This chunk is fairly large, this portion. Those areas are getting counted, and we didn't actually want those in the area that we were looking for. We just wanted the part that was underneath the parabola in green there. And we're getting that plus those extra bits in orange when we use the rectangles. So this estimate is closer, but still an overestimate of what we wanted. Okay. And you can tell that it's closer, by the way, because closer than our estimate with 2 rectangles, because those 2 rectangles came in like this. All right, our first rectangle went right here. And then our second rectangle went right here. There we go, set from 1/2. So if you counted all of the area beneath those 2 rectangles, that has this extra portion and this extra portion. Using the 4 rectangles, we get to cut out those blue shaded bits. So it is getting closer to the area underneath the parabola, but it's still overestimating. So we're making progress, but we're not there. All right, so you might say, okay, well, I'm tired of getting overestimates here. Is there any way that I could get an underestimate for the area? Yes, there is. So that's what we're going to do on this next graph. All right, so here for this one, we are still going to use 4 rectangles, but this time we're going to set them up differently. All right, so this is with 4 rectangles, but we're going to set the height in a different way. So we're going to say 4 rectangles and right endpoints. We're going to use the right endpoint of each rectangle to set the height of the rectangle. So what that's going to look like in the x direction is still the same. We're going to chunk this into 4 equal rectangles. Okay, so each one is a quarter unit wide still. We've got 1/4, whoops, 1/4, 1/2, 3/4, and 1 right there. Okay, but yeah, we're going to use the right endpoint or right side of each rectangle to set the height. So on the first rectangle, you have two sides here. Here's the left side of the rectangle. Here's the right side of the rectangle. Okay, this is the left endpoint right here. This is the right endpoint right here. Okay, it's the 2 points on the x-axis that make the two different sides of that first rectangle. If we're using the right endpoint, we are just going to focus on this guy to set the height for our first rectangle. So we're going to go up here to f of 1/4, and that is going to be the height of our first rectangle. So that is going to come in underneath the parabola in this case, instead of going over the top like the previous one did. Okay, so on the previous graph, we were using the left endpoint to set the height for that first rectangle. All right, this one that we're using for the height, that is f of 0. It's on the left side of the first rectangle, so this was using left endpoints. So we can clarify that up here now with 4 rectangles and left endpoints. We didn't know there was an alternative at the time, but there is. Okay, left endpoints up there. Now down here, we're going to use right endpoints. So that's how we set the height of that first rectangle. For the second rectangle, here's the left side, here's the right side. So that second one, the point 1/2, this is our right endpoint. And we're going to use it to set the height of the second rectangle. So we go up there, and that is going to be the height of rectangle number 2, f of 1/2. Okay, same thing for rectangle number 3. Here's the left endpoint, here's the right endpoint. The right endpoint is at 3/4. So we're going to use this point, f of 3/4, to set the height for the rectangle. That comes in right here. And then for the fourth rectangle, it's going to look a little weird, just warning you. Here's the left endpoint. Here's the right endpoint there at 1. And so we are going to use that right endpoint. We're going to use 1 to set the height of the rectangle. But it so happens here on this function that f of 1 is actually 0. It's one of the roots of our function. So when you set the height of 0, it ends up not looking like much of a rectangle at all. It's just a little flat nothing there. So there's actually no area on this fourth rectangle. No area. Since that height was 0, but it is still how we set up that rectangle though. The right endpoint is still 1 and the height is 0. So that's okay. All right, so that's how we would set it up. So our area calculation here is, well, let's clarify that this is a special area, an A that's different from the previous one. So I'm going to call this A sub R4. R for the right endpoints, 4 is for the number of rectangles. So like our previous one would have been like A sub L4 for left endpoints and 4 rectangles. All right, AL4. The one we did before that, we were using left endpoints and we made 2 rectangles. So that would have been like A sub L2. Okay. But yeah, for this A sub R4, 4 rectangles, right endpoints, we would have the width 1/4 times the height of our first rectangle, f of 1/4, plus, here's our area for our second rectangle right here. The width is still 1/4. The height is f of 1/2. Add the third rectangle. Width is 1/4. Height is f of 3/4. And then our fourth quote, quote, rectangle, that little flat guy right there, width is 1/4, and then the height is f of 1, which is going to be 0. But we'll put it in there for uniformity's sake. Okay. And thankfully, we've already calculated most of these values. F of 1/4 we previously saw was 15/16. F of 1/2 is 3/4. F of 3/4 is 7/16. And then F of 1 is 0. Cool. Okay. So you would crunch those numbers, and with doing it with a fraction, common denominator, you'd get 17/32. Or if you're doing it with a decimal, you'd get 0.53125 square units. But now we can see that this is going to be an underestimate of the area. So this is an underestimate. Okay, because the areas that we're adding together are right here, 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 and then the lack of area on that fourth rectangle. For the area underneath our parabola, we actually want to include this area, that little snub there, this bit, and that bit right there. So our sketch, our rectangles are missing something now. They didn't go over like before, so this is too large of an estimate. We don't really want to include those bits, but we do want to include these bits down here. So what to do? It's kind of an interesting thing here. We got an underestimate and we've got an overestimate. So we just know that the area is somewhere between those two values right now. Okay, so the area is greater than 0.53125, since that was our underestimate, and the area is less than 0.78125, because that was our most recent overestimate. Okay. You might say like, well, isn't there some way we can meet in the middle here, like find something in between? And yes, there is. Our next sketch, we're going to do something else with 4 rectangles. So with 4 rectangles and midpoints. So this is not going to be to the extreme right or left. It's going to be the point in the middle of the rectangle. All right, so when you do these, this is often called the midpoint rule or midpoint sum. So midpoint rule or a midpoint sum of the areas. Okay, so if you see that term, that's just what it's referring to. All right, let's sketch out our rectangles. Gonna set it up with 4 rectangles again, just to keep the number of rectangles uniform here. All right, we've still got that. So each one is still a 1/4 unit wide. But to set the height, we want to go right in the middle of each rectangle. So if this is 1/4 right here, We do not want to use the left endpoint of 0 or the right endpoint of 1/4. We want to go right smack dab in the middle of those two. Okay, we want to go right here, which is 1/8. Now you can calculate that if you are good at working with fractions. 1/4 is the same thing as 2/8. So half of that would be 1/8. Or if you need a more formulaic way to find these, by the way, you can add together the two endpoints, 0 plus 1/4, and then just divide it by 2. That cuts it in half. And so you'd have 1/4 divided by 2, which is 1/8. Okay. So same type of idea for the next rectangle. I'll just put this midpoint right here between 1/4 and 1/2. If you think of it in terms of a common denominator, well, I guess you could say 1/4 and 2/4, but 1/4 is 2/8. This is 4/8, so right in the middle should be 3/8. 3/8. Or you can use the formula again. Add your add your endpoints together. 1/4 plus 1/2, and then divide by 2. Okay, that would be 1/4 is, well, I'll just use 1/4 there, plus 2/4. Keep it simple, right? All right, so that would be 3, whoops, got a little ahead of myself there. That would be 3/4 divided by 2, which is 3/8. Okay, so that's how you could find the midpoints using a formula there. Add together the endpoints and divide by 2. I'll fill in the rest of our midpoints here. Between 1/2 and 3/4, that would be 5/8. And then between 3/4 and 1 would be 7/8. Okay, so that's just locating the midpoint for each rectangle. Now we got to use those midpoints to set the height for their rectangle. So like 1/8 here on the first rectangle, you would go up to the function, and that would be f of 1/8 for that point right there. Okay. So this is f of 1/8. All right. And that is going to set the height for rectangle number 1, like this. Okay. Then on the second rectangle, we would use its midpoint 3/8, go up to where the function is. Okay, that point right there sets the height. Okay, that is f of 3/8 for the height there. Then rectangle number 3, you would use 5/8. Go right here, use that point to set the height. Okay, so your height is going to be f of 5/8. And then for the last one, use 7/8. Okay. That point right there sets the height. Okay, and that point is f of 7/8. Okay, so our area estimate this time around, we'll call it A sub M4 for midpoints and for rectangles. It would be width of 1/4 times f of 1/8 plus width of 1/4 times a height f of 3/8 and width of 1/4. That part gets repetitive, yes. The height on that third rectangle is f of 5/8, and then the last rectangle is 1/4 times f of 7/8 for its area. Okay. Now, with this particular function, you can find the values by hand, or you can just put it in the calculator, either way. Just to kind of demonstrate, I will put the function values in here for you. That way you know that we're still just using f of x equals 1 minus x squared. So they're all over 64 in this case. Okay. So this is what it would look like with fractions, but honestly, most of the time you're probably going to end up using your calculator. So the estimate we get for this is 0.671875 square units. And this one, it's really hard to tell whether this is an overestimate or an underestimate because of the nature of those midpoints. So this might be overestimating or it might be underestimating. It's kind of hard to tell. So on these type of problems, if you're using a midpoint rule or midpoint sum, you shouldn't really be asked if it's an overestimate or underestimate. Sometimes you will get asked on the other types though, the left and right endpoints, is this overestimating or underestimating? But yeah, this one is hard to tell because some parts overestimate, like this little piece, that little piece, that piece, that piece. Those are bits that stick out over the area that we want. But then this piece, that piece, that piece there, and this piece here, those cut in underneath the area that we want. So it's kind of interesting. And you can see that the overestimating pieces and the underestimating pieces are fairly similar in size. And actually, this does turn out to be a pretty darn close estimate for the area underneath that parabola. It's kind of interesting. So you might say, well, are you going to tell us what is the actual area here underneath the parabola? And yeah, none of these are the exact area underneath. We'll get that in the next video.